And welcome back. So in this video we're going to continue focusing on covalent bonds. In this video we're going to look at a special type of covalent bond called a dative covalent bond. So hopefully by the end of this video you should be able to state what a dative covalent bond is. You should be able to represent molecules containing a dative covalent bond, because there's a special way of doing that. Okay, so first of all, the definition. So obviously we know that a covalent bond contains a shared pair of electrons. Now in a normal covalent bond, one electron comes from each of the bonding atoms to form the shared pair. Now in a dative covalent bond, both of the shared electrons have come from the same atom. So one atom provides both electrons, whereas the other bonding atom doesn't provide any for the dative covalent bond. So hopefully this will make more sense once we've gone through an example. So let's have a look at ammonium ion. So hopefully you know an ammonium ion, that's a form of NH4+. It's effectively ammonia, NH3, plus an H plus ion. So first I'm going to draw the structure of ammonia. So nitrogen has the electronic configuration 1s2, 2s2, 2p3. Now I've drawn the orbital diagram for the outer shell, because remember the outer shell is where bonding occurs. And hydrogen has the electronic configuration of 1s1, and these 1s orbitals from the hydrogen overlap with the two unpaired 2p orbitals from the nitrogen to form ammonia. So this is what it looks like as a dot and cross diagram, and I'll just overlap the orbital diagrams as well, just like we did in the previous videos. So this is the ammonia molecule. Now you can see that it contains 3 covalent bonds, but the nitrogen also has a lone pair. Now if we think about what a hydrogen ion is, now a hydrogen atom only contains 1 electron. So an H plus ion doesn't contain any electrons. It is just a proton. So therefore, its 1s orbital is completely empty. So you don't normally write an electronic configuration for this, given that there are no electrons. I'll just put 1s0. I'll just put that empty 1s orbital. So what happens? This H plus ion joins the neutral molecule. So therefore, overall, the molecule has a positive charge. And you can see here that the shared electrons in the covalent bond both come from the nitrogen. Now once the bond is formed, it's just like any other covalent bond. There's no difference. But in the formation of a dative covalent bond, both electrons come from the same atom. So for completion's sake, I'll just overlap those orbitals. So you can see that we have 3 covalent bonds, which are the overlap of s and p orbitals. These are just sigma bonds. And we also have 1s and 2s effectively overlapping, even though the electrons were only in one of them. They still overlap. This is also a sigma bond. So an ammonium ion contains 4 sigma bonds, 3 normal covalent bonds, and 1 dative covalent bond. So last thing is, if you're drawing a molecule for dative covalent bond just using lines, it would look like this. So you would have 3 normal lines representing the 3 normal covalent bonds, and the 4th covalent bond, the dative one, is represented by an arrow. Now, this means that both electrons came from the nitrogen and were shared with the hydrogen. The atom with the electrons is the beginning of the arrow, and the arrow head is pointing at the atom with the empty orbital. So let's look at one more example, and that is aluminium chloride. Now you might be thinking, what? Aluminium chloride? Metal and non-metal? Surely that's ionic bonding. But it's actually not. When we were introducing bonding in the previous videos, I said that covalent bonding occurring between 2 non-metals wasn't strictly true, and this is the example you need to know about, which is the exception to the rule. Now we will go through why this is an exception in a later video, but for now you just have to accept, I'm afraid, that it is actually a covalent bond. So let's draw this aluminium. Okay, so the outer shell of aluminium is 3s2, 3p1. Now the first thing I'm going to do is expand the structure and promote one of the 3s electrons to the 3p. Okay, so it has 3 unpaired electrons, so it can make 3 covalent bonds. Okay, so chlorine has an outer shell with 3s2, 3p5. So it has 1 unpaired orbital. And it also has 3 lone pairs of electrons. So I'm not going to draw all of these because the orbital diagrams for chlorine are too complicated. But you have this orbital here. So for each of the 3 chlorines, it will overlap with the 3 unpaired orbitals of the aluminium. Now, you might be thinking, okay, everything seems to be paired up, but there is this empty orbital in aluminium's 3p subshell. So gaseous aluminium chloride actually exists as a molecule of Al2Cl6. So I'm just going to draw out another AlCl3 molecule. So what happens? You actually get 2 dative covalent bonds being formed. So the orbital containing one of the lone pairs of the chlorine overlaps with aluminium's empty 3p orbital. And this occurs for the second molecule of AlCl3 as well. So you actually get 2 dative covalent bonds being formed. Now this molecule you don't tend to draw as a dot and cross diagram. It's too messy, and you don't know exactly which one of the lone pairs is overlapping just by drawing it with this sort of representation. It tends to just be with lines. So all normal covalent bonds are just a straight line. And then our 2 dative covalent bonds. Remember, it needs to be an arrow, and it needs to be pointing from the atom with the lone pair to the atom with the empty orbital. So, new concept, and these are the 2 more common examples which you may come across. But just remember, dative covalent bond is where both electrons come from the same atom. Once it is formed, it's just like any other covalent bond. And when you're representing it, if you have the dot and cross, like in the ammonium example we looked at, remember both electrons from the same element, so both crosses or both dots. Or if you're drawing lines, it needs to be an arrow pointing from the atom with lone pair of electrons to the atom with the empty orbital. So hopefully you can give a definition for what a dative covalent bond is, and you can represent these molecules either using dot and cross diagrams or with lines and arrows. If you have any questions, make sure you write them down, and I'll see you in class.